So I want to go ahead and talk about replacing the ROMs on the Apple II Plus motherboard with 2716 EPROMs. I want to do this for a couple of reasons. I actually want to use those ROMs in another Apple II build I'm going to do. That's the Rev Zero blank replication motherboard I've got that I want to build out. I've got that one ROM that's got the bad pins on it that are all rotted that I've kind of kludged together into an IC socket we've looked at in a previous video. And so to start down this journey, I went ahead and found the data sheet for the 9316B, which is the revision we have here. And the B has a 450 nanosecond access time, which tells me that all the 2716s I have in my used part stock are all that speed or faster, so they'd all work. They say that the 9316 is compatible with 2716, and it's really close. So let's talk a little bit about the ROMs in the system. Schematic section up here. So we've got these 6 system ROMs on the motherboard. These upper address lines, A11 to A15, are decoded to enable one ROM at a time in the correct address space. So from D000 to D7FF, and then D800 to DFFF and E0, etc. So one of these 6 ROMs can be active at a time. This decoder here takes care of selecting which one is currently active. It does this by bringing these 2 chip select pins low. So pins 20 and 21 are both active low chip selects. Pulls those low, the device is on the bus and being talked to. There's a little bit of a twist to this that we need to talk to, and that's kind of what I've got going on here, is we also need to bring in the inhibit signal here. So if you go to the expansion card edge connectors on the motherboard, there's an inhibit pin there. And an expansion card, by pulling that pin low, can inhibit these ROMs from becoming active on the bus. So if I have a card that has a ROM on it that occupies the same address space as E0 here, and that card wanted that ROM to be active on the microprocessor bus, it would pull inhibit low. That would take the chip select 2 line, which is an active high low, would disable this ROM, and then that board would bring its own ROM onto the bus, and the microprocessor would be running code out of it. So this inhibit line becomes important here because it's how the cards share the ROM address space with the ROMs. So this is kind of the first place we run into an issue here. So pin 18 is this active high chip select 2 right here on the 9316B. Well, on the 2716, that's an active low chip enable pin. So the polarity of this signal is not compatible with the 2716. This inhibit pin is pulled high through this this 1K resistor here in RA01 or RA01. So if there's no cards in the slots, this resistor pulls that pin high. The original ROMs are enabled. So what we need to do is figure out how we can invert this signal and use it as a chip enable. So if this signal was inverted, the resistor would be pulling it high, the inverter would invert it low, and if it was connected to the 2716, the chip would be enabled. We then have the ROM address space decoder here that takes one of these pins low to enable a ROM. And that low signal goes to pin 20 and 21. Well, it turns out on pin 20 we have the output enable, which is an active low. So pin 20 here is compatible with pin 20 in the 9316. So the 2716 can drop in and directly work with the pin 20 here with this output enable. The third thing we run into is VPP here. So in normal read mode, VPP is tied to the VCC pin. It's tied to +5. Well, that's not going to be compatible because this pin 21 is tied to pin 20. So what we need to do to get a 2716 in here is isolate a couple of these pins on each EPROM and invert this inhibit signal. So not wanting to cut traces on the board, or piggyback chips or whatever, I went digging through the documentation, and one of the things I found is there's 2 unused 74 LS100 gates here, 2 unused NAND gates on the motherboard down in location A2. On the Rev 7 and later motherboards, actually on the RFI only motherboards, these guys just aren't used. The inputs are grounded to keep them from oscillating, and the outputs are no connection. And we have this soft 5. A couple of signals here they call soft 5. They're just pull-ups. They're just pulling a signal up to a 1. In the earlier rev motherboards, for whatever reason, they grounded the inputs, which of course these become inverters then, so these two soft 5 outputs go high. And they're basically used deeper in the system, but they're always a 1. So my thought is to hijack this device right here to become the inverter I need for that inhibit line. And using some wire wrap on the board, running some small wires around and bending some pins up, I should be able to do this. I believe, and we'll talk about this a little bit later, is on these non-RFI motherboards, you could actually steal this gate here as well. And what you'd want to do in that case is just take these two soft 5 signals here and jump them together with that gate isolated. So what this might look like in practice would look like this. So I'm taking a device with this pin out and I'm putting a device with this pin out in place. So what I've drawn here, where these larger pin representations are, where they stick out further, indicates a pin I have bent out, so it's not actually plugging into the socket. So I would program up my 2716s with the appropriate ROM image for each location. I would bend up the VPP pin, pin 21, and I would use a jumper wire to jump it to VCC. So this pin's bend up, it's not plugged into the socket, it's tied directly to VCC across the devices. I would then take the chip enable pin, and I would also bend it up so it's not connected into the socket. I would hook all those together. I would go to that 74LS100 device at A2. I would bend the pins on this gate here out so they're not in the socket, and I would hijack those pins. I'd grab the inhibit signal at this resistor pack, bring it over to the two inputs tied together. That turns this just into an inverter. And the output, so in the normal operating mode, inhibit's pulled to a 1. That 1 gets inverted to a 0, and the ROMs are enabled on the bus. If a card in an expansion slot takes inhibit low, that low gets inverted to a high, and these guys are disabled on the bus. So I believe on the RFI motherboards, this is drawn here will work just fine. I actually believe on the earlier generation motherboards, you could basically do the same thing here, only you would have to add one wire jumper underneath the board. So this would be between the pins on the IC socket from pin 8 to 11. And what this has the effect of doing is it isolates this one NAND gate here by bending these 3 pins out. And then underneath the socket, we take pin 8 and connect it to pin 11. And what that's doing on the socket is kind of what I've drawn here, is it's connecting. I think this mod would work there as well. So scroll back up and make sure we've hit everything I wanted to talk about. I'm confident my EPROMs will be the right speed. The pinouts are very close. We've acknowledged we need to worry about the inhibit, and the 3 red arrows here pointed at pins that are slightly different, at least need to be thought about. We've discovered there's 2 extra NAND gates on the board, which we can actually use, which is nice. Don't have to piggyback a chip any place. And ultimately, this is what we're going to do. So let's go ahead from here and jump in to actually trying to get the board in this configuration. So there's really only one way to see if what I described earlier in the video is actually going to work, and that's to actually try it in hardware. So I've got enough of the Apple One hooked up here to be able to power it up. Let's go ahead and power it up and just make sure we get the system prompt, which we do. So we get into the basic. I then want to remove one of the ROMs. I'm going to target the F8 one, which is the one where I've got the kludge socket mess in place. And the system, I believe, will come up with an error with that ROM removed. And of course it's off the top of the screen. But there it is. So we do power up with an error message. So we know that ROM is not being seen by the system. So what I'm going to do is only try to replace this ROM with the mod that we've come up with here and see if I can get normal operation. And if that works, I will probably go ahead and replace all the ROMs. So let's jump in and do that. So let me power it off here. Get it disconnected. Okay. Hopefully this is all in frame. Let me check the camera. Yeah, it's not too bad. I need to pick up this inhibit signal here that comes from the card edge connectors. It looks like I can pick that up at RA01 pin 7. RA01's a resistor pack. It's sitting in there. And what I'm going to attempt to do is unsolder pin 7 so I open the hole up, and then feed a piece of wrap wire down through and resolder. Then I'll route that wrap wire down. The other thing I need to verify, because I actually haven't, is if this gate is actually unused on A2. And to do that, let me get the ohm meter fired up here, and we'll just check a couple quick things to convince ourselves that it actually is unused. So I'm in continuity. I'm going to get on ground, and what I should see here is pins 13 and 12 are tied to ground, and indeed they are. So that with pins 13 and 12, those two inputs tied to ground, that tells me that that gate in this revision of the motherboard isn't used. We looked on the earlier video at the earlier motherboards where that gate's actually used, but there's a way to do the same mod on the earlier version motherboards. So got the Heiko warmed up. I've added fresh solder to all the pins on the resistor network. And let's see if I can successfully unsolder it and get it to drop out of there. Can't I get on that pin? Is it bent? It is bent. Well, the question is if I... Okay, it's moving, which is a good sign. Oh yeah, it's going to fall right out. So let's grab a pair of needle nose. Let's see if I can get him to pluck up out of there. He might be really fun to get back in, honestly. That bent pin is a little... Sorry if I'm off camera here. A couple of the pins were bent to hold it in place while it was soldered. And I've got that piece of wrap wire we prepared. Feed it down through the hole. And I'm going to kind of tie it off here. So hopefully it'll stay in place. And now the question is going to get the resistor network back down through there. And pin 1 is there, so it goes in this way. This is going to be touchy with that edge connector right up against the set of holes. And it dropped down into place. Our wire's still in place. Let's do our best to tape that into place so it won't lift up out of there while I flip the board over. We've got our piece of wrap wire coming through on pin 7. 1, 2, 3, 4, 5, 6, 7, 8. We turn this guy off and we can resolder the resistor pack in. Can't see through the tape to double check pin 1, but I was careful when I put it in. I'm just going to tack the 2 end pins for now. And yeah, it has to be right. Just looking for the pin 1 identification. So let's solder this up. Hopefully this is somewhat on camera. Trim off the excess wrap wire. And we have tapped off that inhibit signal. So the Heiko's still hot. I'm going to set it out of the way here. I really need to clear the bench off. I've got too much going on the bench. You go down there to cool off. And I'm just going to simply route this wire down the board and across to A2 and to the pins we need to pick up. So let's get A2 out of there. A2 is out. For the drawing here, I want to bend up pins 11, 12, and 13. So that will be 13, 12, and 11. And this is just a 74 or 7400. So I'm not too worried about, you know, if this doesn't work recovering the device. I'll just put another 7400 in. So I'm going to go ahead and trim the pins off on him. Get him back into the socket. I should have enough room. Did I bend a pin getting him out of there? There he goes. Down in, it's a little tight up against this transistor. I'm going to go ahead and shorten the leg stubs up a little bit more here. There's enough clearance there, but I can trim these back a little bit further. I need to actually get another piece of blue wrap wire with some length to it. I'm going to go ahead and pre-attach this wire. Yeah, the bench is a mess. I'm sure I'm working off camera here. Apologies. Let's just go ahead and tin these legs up. The three we bend out. Let's take the piece of wire we just cut. I stripped a little bit off the end. I'm going to trim it so just a tiny little bit of wire is exposed. I'm going to tack it right into place here. Hopefully this is on camera. It barely is. I'm sorry for the jerky motion there. I actually have a custom built camera mount above the bench. It lets me move the camera around, which is what I just reached up and did. With the camera actually active, so you got messy video. I've of course dropped the part down onto the floor. So the part's going to go in. Here again, it's a bit of a battle to get it in there. This lead will go off to, I believe, the chip enable. I'm going to route him down this way, and I'm going to, for now, leave quite a bit of extra length. I can come back and trim this to perfect length later. Use a little hot glue to tack the wire in place if this works. Strip off enough there. What I want to do is jumper this across those two pins. I have just enough length to do that. That looks really good. So inhibit is now brought to pins 13 and 12, and the inverted inhibit is brought out. I'll just kind of tack this wire down a bit here someplace for now, just to kind of hold it out of the way. I've got the set of ROMs here someplace. We are looking for ROM F0. Let me dig through and find F0, E0. I went ahead and programmed a second set of EPROMs from, not the ones I programmed in the video a while back. I've got a ton of these AMD ones. And so I went ahead and just programmed a set of those, because if this fails, I've got lots of these. It's not going to be horrible to lose one. Whereas with the older style ones, with the older style package, I really don't want to lose those. So we're going to take pin 21 here, which is VPP, and we're going to bend it up out of the way. And we're going to trim it back. If I can get it to cut. Oh. A pair of side cutters are shot. And that's going to be jumpered to pin 24. And then we're going to bend up pin 18, so 21, 20, 19, 18. Doesn't seem right. Yeah, there's 2 pins in between, so it's data 3, 4, 5, 6, 7. Chip enable. We're going to bend him up and trim him back as well. I realize I'm doing a lot of this off camera. Let me get a bit of solder on the 3 pins that are required here. So we're going to attach that inverted inhibit signal here. And we're going to jump our VPP here up to VCC. I'm just going to get a little bit of solder on there as well. I don't want it running down the length of the pin. I'm actually going to use a piece of red wrap wire to do this, just because it's the 5-volt rail, and red to me means 5 volts. I'm actually going to trim a fair amount of length here, and I'm going to bring him up like so. And wrap him around once. And then we will solder that in place. Good enough. Trim off the excess. Myself enough lead length here to be able to strip this. He's going to get stripped to about there. Just simply take the other side and attempt to wind it around the little pin stub I have left. We'll apply a bit of solder to that to make sure we've got a good connection. The extra lead gets trimmed off. He's going to go down into the socket here. The pins on this guy are not the straightest, so this might be a little bit of a challenge to get in. Feels like it went okay. And for this test, I'm going to leave the inhibit not signal fairly long here, because if this works, I'm going to replace all the ROMs. I'm just going to tack that onto the chip enable pin if I can see it. And with that, we've picked up inhibit, we've inverted it, and we brought it to the F0 ROM. So at this point, the next thing to do is to get the video hooked back up. Get the Apple II's power plugged in. Let me get the other camera recording here, so you can see the results live with me. Video, record, and hopefully we will get the Apple II prompt, and we got absolutely nothing. Oh, I know why that is, because the power supply isn't plugged in. I unplugged the power supply for the Heiko soldering station. Perfect. Well, that right there tells me that this is actually a workable fix to replace these ROMs with EPROMs on the board here. I really want to use these ROMs on my Rev Zero board. Ooh, that's not a good thing. So it's a nice little mod. I think I will go ahead and I'll do this off camera and convert all the other EPROMs over, get them in the sockets with the little jumper lead for VPP, and then tie all the chip enables together and bring this signal up to the chip enable here. And this should be interesting. Very nice. Well, we can't say definitively this is working at this point. I believe it is. We know that it inhibits pulled high, which has produced a low, for that EPROM to be able to be seen on the system. The question is, if I put in the disk controller, will it boot? The problem is I don't know what ROMs get disabled here for various cards in the system, so nothing says that this is a definitive test, although it's trying to boot. So that actually needs the memory card put in. I'm very confident this is correct, but until we know the inhibit actually works and the system can inhibit the ROMs on the motherboard to enable ROMs on cards, we really don't know for sure. So it is attempting to boot here. You can see it on the screen. So what would be a good test here? Maybe put a few more cards in. See what cards I have laying around I can put in. We'll add a few more cards. It'll increase my confidence a bit. Here is a Super I/O. Serial card. Here is the floppy controller that I have a kludged fix in place for that needs to be actually repaired permanently. I have a untested card here, which we'll test here in a second. So you have two untested cards. Let's see where we are at this point. Okay, that's still a good sign. I am going to need a keyboard for this because I want to be able to actually go in and interrogate the bus and see if it's seeing all the cards. So let's get a keyboard hooked up. This is a GravStar parallel printer interface card that I picked up today. I don't know what address this EPROM maps in at, but I'm going to go ahead and add that card. This was occupying a slot here. If I can actually get it to plug in. Can I get, oh, I don't know why that won't plug in because I've got that little, that's the socket with the bad lead in it. But I really don't want to be plugging anything into, honestly, so I'm not going to plug it in there. I will drop it down in here. I don't know if there's actually positions these cards are supposed to be in. Do we still power up? We do. And I picked up a Z80, I assume it's a CPM card, that I think actually goes up here in slot 7. Again, it's completely untested. I know nothing about it. But we'll go ahead and boot up here the computer inspector and just see what it shows in the slots. So machine identification, language card, printer, super serial, disk 2 card, disk 2 card. I don't know if it would actually see that Z80 card or not. This is a better indication that we might have an operating system here. So again, don't know totally enough about the hardware to know, because what I need is something that occupies that F0 address space to come live here on an expansion card, so that card's inhibited. Anyhow, I'm going to strip this down at this point, replace all the other ROMs, and I'll come back and pick up video after that's been done.